Welcome to Pixel Perfect, the image sensor podcast. Join host Manu and image expert Emma.
Welcome back, everyone, to Pixel Perfect. I'm Manu, and if you remember in our last deep dive, we kind of, kicked off this whole journey into the world of custom camera modules, the ones CamMake builds,
Right. I'm Emma, and I'm excited to, help you guys navigate this whole world.
This time we're going beyond just the basics.
Yeah, we're going deep into what you, our listener, needs to tell us at CamMake to really get the ball rolling on building your perfect camera module. It's almost like we're giving you the instruction manual.
But a way more interesting instruction manual.
Definitely. Choosing a camera module, let's face it, it's not as simple as just grabbing the one with the highest megapixel count.
Oh, so it's not all about megapixels.
No, it's more about figuring out, the why behind your camera.
The why? What do you mean by that?
Okay, well, what's the camera going to be used for?
The application.
Exactly. Imagine the difference between, a security camera keeping watch over a dimly lit warehouse versus a tiny camera that's inside some medical device. Those are totally different stories, different demands.
Makes sense. So how does CamMake take those different applications or stories and turn that into a camera?
That's where the magic happens. Once we know the camera's purpose, we use that information to guide, every decision we make, from the sensor we choose to, the lens, even the materials. Will your camera be facing rain, snow, scorching heat? Will it get jostled around? All that matters.
I never thought about a camera needing to be, rugged. I just assumed they're these delicate little things.
Not necessarily. Think about if you're designing a camera for a drone zipping through the air, or a piece of industrial equipment that's constantly in motion. It needs to be tough.
Okay, that makes sense. So let's move on to the star of the show, the image sensor.
Right.
What is it, and why should I care?
It's the heart of the camera, the chip that captures the light and transforms it into an image.
Okay.
And while resolution is important, the megapixels, it's not the only factor.
So a 2-megapixel sensor might be perfect for a simple task, but a high detail, like scientific application, might need a 200-megapixel beast. Right?
Yeah, exactly. And there's more to think about than just still images. Imagine capturing the blur of a hummingbird's wings in high-speed video. You'd need a sensor with a super high frame rate to freeze every fleeting movement.
So we have to consider the speed at which the camera needs to see the world.
Yes.
Okay. So we've got resolution and frame rate. What else goes into picking the right sensor?
Well, are we shooting in color, or are we going for that classic black and white look? Monochrome sensors can be really great for some applications, especially when color isn't critical.
So CamMake looks at all these factors, the resolution, the frame rate, even whether I want to see the world in color or black and white, to figure out the best sensor for the job.
Precisely. We also need to know, does your camera need to see in near darkness, or will it be bathed in sunshine? Does it need to capture really fine details and shadows and highlights? These performance needs all help us pinpoint the perfect sensor technology for your specific vision.
This is fascinating. We've got the eyes of our camera figured out, but what about how it actually sees? That's where the lens comes in, right?
Oh, you got it. Lenses are like the camera's window to the world. They determine how much of the scene your camera captures and how sharp that image is.
So we've got fixed focus versus autofocus.
Right.
But you've also mentioned fisheye lenses and endoscopic lenses. What's the deal with those?
Those are our specialty lenses, the ones that bring unique perspectives to the table. A fisheye lens captures a super wide view. Think like a security camera, needing to keep an eye on an entire room.
It's all about the big picture.
Exactly. And endoscopic lenses.
Yeah, those are for looking inside the human body or machinery, right?
Exactly, for tiny spaces.
Yeah.
So the lens determines what the camera sees, but how much of the scene does it capture?
Well, that must be where field of view comes in, right?
You're right on track. Field of view, or FOV, is like your camera's peripheral vision. Think about how much you can see without turning your head. A wide FOV means you're taking in the whole scene. A narrow FOV is more like looking through a tunnel.
Okay, I get it. And then there are filters. I know those can completely change the look of a photo. How do they work in a camera module?
Filters are like sunglasses for your camera. They control what light reaches the sensor. An IR cut filter, for example, blocks infrared light, keeping colors accurate.
Interesting. I've always wondered why some photos look overly red.
Yeah, that can be infrared light messing with the colors. An IR cut filter helps fix that. Then we also have bandpass filters. It's like a VIP pass for specific wavelengths of light.
Mm-hmm.
They only let certain colors through, which can be super useful for, scientific or industrial applications.
Okay, so filters can really fine-tune what the camera captures. Now let's talk about something I've always been confused about, depth of field.
Depth of field is all about what's in focus and what's blurry in an image. Think about like a portrait photo where the person is sharp and the background is beautifully blurred. That's a shallow depth of field.
Okay.
Now imagine a landscape photo where everything from the foreground to those distant mountains is in focus. That's deep.
Ah, I see.
It's like choosing how much of the scene you want to be sharp.
And the lens helps control that.
The lens and the aperture, yeah.
Wow. We've covered so much. We've talked about the sensor, the lens, and even how filters and depth of field shape the image.
Mm-hmm.
What else do we need to consider to build this, this perfect camera module?
Well, we've tackled the seeing part. Now we need to think about the camera's physical form. How does it fit into your final product?
Okay, so we're moving beyond just the optics into the actual hardware.
Yeah.
What do we need to think about here?
Well, size is obviously crucial. A tiny camera for a wearable device has totally different size constraints than, say, a large industrial inspection camera.
Yeah.
We need to know how much space we have to work with and how the camera will be integrated into your product.
Integration. What does that mean when it comes to cameras?
Think of it as, how will the camera physically become part of your final product? Will it be tucked inside a smartphone or mounted on a drone? The integration method can really influence the design.
I can imagine fitting a camera into a sleek smartphone is different than, like, bolting it onto some big piece of equipment.
Exactly. And speaking of the camera's physical construction, we also need to consider the PCB.
Oh, the PCB. I know it's important, but I'm not really sure what it does. Can you break that down?
The PCB is like the nervous system of the camera module. It's the foundation that connects all the components, the sensor, the lens, the processing chips, and it allows them to all talk to each other.
So the PCB is like the backbone that holds everything together.
Exactly. And we have different types of PCBs to choose from, depending on your needs. There are rigid PCBs, which are sturdy and great for applications where space isn't an issue.
And what about when space is an issue?
That's where flexible PCBs come in. They can bend and twist, perfect for compact devices, or applications where the camera needs to, fit a curved surface.
Flexible PCBs, that's cool.
Yeah.
What other options are there?
We also have rigid flex PCBs. Those combine, the best of both worlds. They have rigid sections for components that need the stability and flexible sections where things need to bend. And for really complex designs, we even have stacked PCBs, multiple layers stacked on top of each other.
Wow. There's a whole world of PCBs out there.
There is.
How does CamMake choose the right one for the customer's camera?
We consider things like, the available space, how much flexibility is needed, and the overall complexity of the design. So if you're building a camera that needs to fit inside a foldable phone, for example, we might need to use a flexible PCB.
Oh, I see. To allow for that bending.
Right.
Okay, so we've got the sensor, the lens, and the PCB. What else is missing from our camera puzzle?
We can't forget about connectors.
Oh, right.
They're the bridges that allow your camera to communicate with the rest of the system.
Yeah.
It's like making sure your camera speaks the same language.
So things like MIPI, USB, SPI, are those the languages?
Yeah, you got it. Those are different interface types, and each one has its strengths and weaknesses. MIPI, for example, it's designed for high-speed data transfer, ideal for video.
Oh, so if I'm building a camera for a self-driving car, MIPI would be a good choice.
Exactly. But if you're just capturing still pictures, something like USB might be a better fit. It's all about finding the right tool for the job.
It's amazing how many details go into designing a camera module. Definitely more complex than I ever imagined.
It is. And we're not even done yet. We still need to talk about how the camera talks to the system, the power, and making sure it can handle real-world conditions. But we'll save those fascinating topics for the next part of our deep dive.
All right. Can't wait.
Taking a moment to remind you, if you're inspired by what you're hearing and want to learn more about how CamMake can help bring your imaging projects to life, head over to cammake.com.
We covered a lot of ground in the first part, but you know what they say? The devil is in the details. And when it comes to building a camera module, well, those details are exactly what we need to talk about next.
All right. Bring on those devilish details. So we just finished talking about connectors, which is how the camera physically connects to the rest of the system. But how does the actual communication happen?
That's where the communication interface comes in. You see, it's kind of like choosing the right communication style. Like, you wouldn't use technical jargon with a child, right?
Yeah.
Keep it simple. So are you saying different interfaces are better for different types of data?
Precisely. For example, video data, like a high-speed train, tons of information every second.
Yeah.
So an interface like MIPI is designed to handle that speed. Okay, so if I'm building a camera for, let's say, a self-driving car, which needs to process so much visual data all the time, MIPI would be a good option.
You got it. But if you're working with something that doesn't need that constant stream of data, like a camera that only captures a still image every few seconds. Yeah.
Then a slower interface, like USB, might be a better fit.
So it's not just plug and play. It's about making sure the data can flow properly.
Exactly. And speaking of efficiency, we can't forget about power consumption. Especially these days, with everyone so concerned about battery life on their phones and everything.
Low battery is my biggest fear. So how does power consumption play into all of this?
Well, we need to know how much power your camera is allowed to use and what voltage it'll be operating at. For example, a tiny camera in a fitness tracker running on a tiny battery, that can't be guzzling power.
Right.
It needs to sip energy carefully so the device can last all day.
I see. This makes me realize how important it is to really give make all those specific details about my project. It's not just about the camera, it's about the whole system, right?
You got it. The more information you give us about your application, the better we can design a camera that fits your exact needs.
So it's not just, I need a sensor and a lens.
Right.
It's, how do these choices impact power, data transfer, and the size of the module? Exactly. It's all connected. Now, let's not forget about the environment our camera is going to be living in. Will it be facing the elements? Will it need to, withstand extreme temperatures, get knocked around?
Right. You mentioned earlier that not all cameras are delicate. Some need to be built tough.
Exactly. Think about a camera on a drone, flying high in the air, exposed to wind, rain, maybe even a bird attack now and then.
Right.
Or a camera used in, a factory surrounded by heat, vibrations, dust. Those cameras need to be built like tanks.
So how do you make sure they can handle those kinds of tough conditions?
That's where environmental specifications come in. We need to know the operating temperature range, the humidity levels, potential exposure to dust or water.
I see.
And we use things called IP ratings.
IP ratings. I've seen those on electronics, but I've never really understood what they mean.
An IP rating is like a shield. It tells you how protected the device is. It's got 2 digits, like IP67, for example.
Okay.
The first digit tells you how resistant it is to solids, like dust, and the second to liquids, like water.
So a higher IP rating basically means better protection.
Right, exactly. So a camera with that rating, IP67, it means it's totally protected from dust and can even be dunked in water up to a certain depth. Knowing the IP rating helps us choose the right materials and designs to, really protect that camera.
This is starting to sound like a spy movie now.
A little bit, right.
Secret codes, rugged designs.
Well, there's a lot of cool technology that goes into making sure a camera can withstand the real world. And even then, we're not done. We still need to test it.
Testing?
Yeah.
I mean, more than just pointing it at something and taking a picture.
Oh, yeah. It's much more than that. We have a whole bunch of tests to put your camera through its paces. Making sure it can handle everything it's supposed to.
Like what kind of tests?
Well, we might subject it to extreme temperatures, shake it around, even drop it.
Wow.
To see how it holds up. We'll check its image quality in different light, how it performs at different frame rates. We need to make sure it can communicate with the rest of the system, too.
So it's not just, does it take a picture? It's, does it meet all the criteria?
Right. The right resolution, the right field of view, the colors, all of that.
And then there are industry standards and certifications you have to meet.
Exactly. Things like FCC and CE markings.
I see those on everything.
Right.
I never knew what they meant.
They mean the device has passed certain safety and performance tests. We also have to make sure it's RoHS compliant, which means it doesn't have certain hazardous materials.
Does CamMake takes care of all that?
We do.
That's a relief.
We handle the testing and certification to make sure your camera is not only high performing, but also safe and, legal.
That's great. You handle all the behind the scenes stuff so I can focus on, actually using the camera.
That's the idea. We want to make the whole process easy for our customers.
Speaking of making things easy, we haven't even talked about production volume yet. What if I need, hundreds or even thousands of cameras?
That's a great point, and it's something we consider right from the start. Whether you need a few prototypes for testing or a huge production run, we've got you covered.
So you can handle small batches and mass production.
Absolutely. We also think about, the long-term availability of components. We don't want to run into a situation where we can't build your camera because we can't get the parts.
Makes sense. So it sounds like CamMake really does have every step of the process covered.
We aim to be your one-stop shop for all things camera modules, from, that initial idea to that final product.
So we've covered testing, compliance, production. Is there anything else before we wrap up this deep dive?
We've laid a lot of groundwork, but there's always room for extras, right?
Ooh, extras. I like the sound of that.
So let's talk about some of those extra features that can take your camera to the next level.
All right, what kind of cool stuff are we talking about here?
Well, for starters, let's talk about focus. Do you need autofocus? Where the camera automatically keeps things sharp?
Yeah.
Or would you prefer manual focus, where you have, total control?
That probably depends on the application, right? A security camera that's constantly scanning probably needs autofocus. But a scientific camera might need manual focus for precise measurements.
Exactly. Right tool for the job. And then there's the data output. How do you want your camera to deliver the image or the video?
So we're talking about file formats.
Yeah.
Like JPEG for images and...
Yeah, MP4 for video, you got it. But it goes beyond those common formats.
Okay.
We can output data in RAW format.
RAW?
Yeah.
What's that?
It's uncompressed data. All the information the sensor sees, basically. Like getting raw ingredients before you cook, you have all the flexibility to process and adjust it later.
Interesting.
So, yeah, you can adjust the colors, the exposure, get every detail.
But aren't RAW files really big?
They are. So if storage space is limited or you need to transfer data quickly, compressed formats like JPEG or H.264 are better.
I see. So you can tailor the output to match the needs of my project.
Of course. We can even do some pretty advanced stuff like AI processing or external synchronization.
AI processing in the camera?
Imagine a camera that not only sees, but actually understands what it's looking at.
Whoa.
That's the power of AI. We can build algorithms that let the camera recognize objects, follow movement, even make decisions based on what it sees.
Wow.
And with external synchronization, we can connect multiple cameras together, have them capture images or video that are perfectly in sync.
Oh, wow.
Imagine a system with several cameras working together to create a seamless 360-degree view.
That's incredible.
It is. We're not just capturing images anymore. We're creating experiences.
Wow. So we've gone from seeing to perceiving to interacting with these cameras.
You got it. These advanced features, they can really take things to another level. But we'll save those discussions for another time.
All right. This has been such an eye-opening conversation.
I'm glad.
But before we get too carried away with AI and, synchronized cameras, let's bring it back down to earth for a minute.
Good idea.
What are the key takeaways here for our listeners? What should they be thinking about if they're, starting this camera journey?
The most important thing to remember is that building a camera module, it's a collaborative journey. It's not about just handing Cam, make a list, and waiting for a camera to magically appear.
Oh, okay. I see what you're saying.
It's about working together, sharing ideas, understanding what everyone wants to achieve. It's about good communication and a shared passion for making something new.
It's like a partnership.
Exactly. We want to be more than just a manufacturer. We want to be your trusted advisor, your partner, helping you bring that vision to life.
I like that.
It's about building cameras and relationships.
That's a great way to put it. So our listeners are probably thinking, okay, I want to build a custom camera. Where do I even begin? What's that first step?
The first step is easy. Reach out to CamMake. Tell us about your project, your challenges, your dreams. Let's start talking, explore what's possible, and together we'll build something amazing.
It really is all about that teamwork, isn't it?
Mm-hmm.
And I think our listeners are starting to realize that building a camera is, it's a lot more than they might have thought.
It's not just point and shoot, right?
Right.
There's a whole world of tech behind that.
We've talked about everything from the sensor to the lens, the housing, the software.
And we've only just scratched the surface.
I know. There's so much more to discover.
There is. It's fascinating.
So if someone's listening and they're thinking, okay, I'm inspired, I want to build a custom camera, where do I even start? What's the first step?
Honestly, the first step is just to embrace that inspiration, Don't be afraid to think big. What's possible? What do you want your camera to do? What problem are you trying to solve?
Those are good questions.
They are. And once you have that vision, even a blurry one, you got to define those specifics. What are the must-haves for your camera? the nice to haves? What are your limitations?
Right. All those details we talked about, the resolution, the field of view, the environment, the interface.
It's like putting together a puzzle, right?
Yeah, high-tech puzzle.
Exactly.
And once you have those puzzle pieces in mind, that's when you call in the experts.
Absolutely. That's when you reach out to CamMake, tell us your vision, share your questions. We love a good challenge.
That's the beauty of custom camera modules. There's no one-size-fits-all. It's about finding the perfect fit.
And that's where we come in. We'll work with you every step of the way to make that vision a reality.
Building cameras, building partnerships.
Exactly. That's what makes it so fun. It's about the collaboration, the learning, pushing those boundaries of what's possible.
So I think everyone listening has learned a lot about camera technology today.
Hopefully.
But before we go, I want to leave everyone with one last thought. Next time you use your smartphone, your laptop, or even, step into a self-driving car, think about all that amazing tech that's capturing and processing the world around you.
It really is amazing, isn't it?
It is.
It's a world of light and shadow and so many possibilities. And anyone can be a part of shaping that world,
I love that. So that wraps up our deep dive into the world of custom camera modules. Thanks for joining us. Until next time, keep exploring, keep innovating, and keep capturing those amazing moments.